Hello and happy, let's see, what is today? Happy Thursday. Um, we are continuing on with our practice of multi-step equations, distributing, polynomials, fractions, all of the good things that we've been talking about. And I only have 2 problems for you today. I don't have any PDFs to upload, so you'll have to watch this video to see what your problems are so that you can upload them. Not enough of you are watching these videos. So yesterday you had a maze, and the maze was practice with your exponents. So when you multiply a coefficient that's got variables to another coefficient with variables, you multiplied the numbers, and then you added the exponents that had similar letters. So if this x over here was to the power of 3, and it was multiplied by an x over here to the power of 2, you just added those exponents and kept your x. And so you guys had practice with your exponents yesterday when you were distributing and multiplying. But today I want to work on distributing and multiplying with fractions, because I know this is difficult for you guys, and the more practice we get, the better as we continue to go on in math. So I have 3 problems for today. I'm going to do one with you, and then I'm going to write the other 2 out, and all you have to do is write them on a blank piece of paper. And sorry, there's a glare. All you have to do is write them on a blank piece of paper and upload your 2 problems, and that's it for today. So let's go ahead and flip to the paper. I will show you problem 1, and then you'll have to do problem 2 and 3 on your own. Now again, this is just on a blank sheet of paper, so this does not need to go in your notebook. But for problem number 1, we have 3/4 multiplied by 2 minus 3x set equal to 7/2. All right, so what we have to do first, always, is simplify our equation. If there's ever parentheses, PEMDAS, we have to get rid of the parentheses first, distribute that, and simplify our equation, and then we start working backwards from PEMDAS. So we do anything that can be added or subtracted away that's just a plain number or constants, and then we either multiply or divide to get rid of those things that are stuck with x. So first I'm going to distribute, just like we do every other time, to both parts inside of this parentheses. However, since this is not a whole number, I know some of you guys are wondering, okay, so what is 3/4 times 2? I can't just do that in my head. But what you do is you make any whole number a fraction of putting it over 1. I talk about my imaginary ones, invisible ones that are everywhere. So at this point, we know when we multiply fractions, we just multiply the numerators times the denominators. So I'm just going to do 3 times 2 and get 6, 4 times 1 and get 4. So 3/4 times 2 is 6/4, minus 3 times 3 is 9, keep that x, and then 4 times 1 is 4. And then just bring everything else down. Simple enough so far. Now, I have to move away any numbers, so I'm always looking at the side where x is. X is on this side of the equal sign. And I know some of you guys like to write your problems like that. So you keep your equal sign lined up and you can see this side versus that side, and it helps. So if my x is on this side, I've got to start moving things away. So first we get rid of any numbers that are just by themselves. So this 6/4 is a number. It's not a pretty number. It's not a perfect whole number, but it's a number. So we're going to get rid of it. I know that this is a positive number because there's no negative sign out in front of it. So the opposite of positive 6/4 is negative 6/4. So I'm going to subtract it away. And as always, what you do to one side, you do to the other side. So now that's gone. And I can do 7/2 minus 6/4. But we know when we add or subtract fractions, they have to have the same denominator. Now up here, when we multiplied our numerator and our denominators, it didn't matter if they were different. It's just multiplying. However, when you add or subtract, they have to have the same denominator. So we've got to get these to both have a 4 underneath them. Well, this one's got a 4, but this one needs to be a 4 as well. And the reason I chose 4 is because I know that 4 is a factor of 2 and 4 is a factor of 4 as well. So I just chose the smallest number that can go into both of these numbers, which is 4. So to get this to equal 4, I multiply the top and the bottom by 2. So this would actually be 14 over 4 minus 6 over 4. 14 over 4 is the same fraction as 7 over 2. This is just the reduced version. So if I divided both these numbers by 2, I could reduce it down to this fraction. So I haven't changed the value, I've just made it a bigger version of the fraction. So now I can just subtract my numerators. 14 minus 6 will give me 8 over 4. Now this, I know a lot of you are thinking, oh, that's a nice number, that's nice and pretty. If we have 8 divided by 4, that really equals 2. So when we come down here, we're going to bring negative 9x divided by 4 down. Our equal sign is still right here in the middle. And 2 is what's left over on this side. Once we finally did 7 over 2 minus 6 over 4, we gave them the same denominator, and then we got our reduced fraction. So it actually comes down to just 2. That's the only thing we have left. So now when we look at our x over here, we're trying to get it by itself, we can see, all right, there's something that is dividing and multiplying to it. But you cannot get to anything up top until this denominator is gone. Think of the denominator as like a prison. It holds everything up top until you get rid of it. So the opposite of division is multiplication. So if we want to get rid of divided by 4, we have to multiply by 4 to both sides, leaving us now with negative 9x equals 8. And then this represents multiplication. So to undo multiplication, we divide. And what are we trying to get rid of that's stuck to that x? Negative 9. And so x now equals negative 8 over 9. We can't reduce that fraction anymore. If you can, like this one, go ahead and make it a nice whole number. If you can't, you can leave them just as fractions. And even if you want to leave it as an improper fraction, it's not wrong. So number 1, the answer is negative 8 over 9. That didn't take too long, but you just have to be very careful with each step that you're doing the right order and you're not multiplying or dividing before you've added or subtracted. So if we look at this problem up here, when I had this part right there, 6 over 4 minus 9 over 4 equals 7 over 2, it would have been very catastrophic for me to start multiplying all of my numbers by 4 and then subtracting a 9 away and just kind of going all out of order. Any number by itself gets moved. And I know some of you are probably thinking, well, wouldn't I multiply this? And you can, but even though this is a weird fraction, just go ahead and get rid of the whole thing. Like we need all of this gone, not just the denominator. We don't need to just get rid of divided by 4. We need to get rid of the whole thing. So let's just subtract it away and then work on this and break this down. So the 2 problems I want you to work on today. Number 2 is negative 1 over 8 multiplied by negative 2x minus 1 set equal to 9 over 8. So you're going to distribute this in to both, get your new numbers down here, and bring down equals 9 over 8. Remember, these whole numbers can be turned into fractions over 1, and then you just multiply your numerators and your denominators and simplify if you can. Then you're going to move away any number that's not attached to the x, and then you'll start breaking down things that are stuck to the x. And then number 3 is going to be 2/3 6 minus 9x plus 15 equals 55. Again, we're distributing this in and turn both of these into fractions by putting them over a 1, so you can multiply your numerators and your denominators. Bring it down and combine any like terms. So right here, this is a number multiplied by a number, which is going to give you a number. This is a plain number. So when you get down here, you should be able to combine like terms and then move your numbers and get rid of anything stuck to the x. So these are the 2 problems that you'll do on a piece of paper on your own, and you will submit them to me today. Good luck to you all, and if you have any questions, remember you can always comment in the Google Classroom, or you can set up a Zoom with me, and I can help you one-on-one, but you've got to make sure that you're reaching out and letting me know what you need help with. That is all you have for today. I will see you guys tomorrow.